kilometers.
So do you have a little sketch that we could look at?
Yeah, it's kind of.
Okay, well mine's not, I don't have a great sketch, but let's see your sketch. I'm glad to show you. Anybody else do a sketch? Anybody else need to? Nobody? Okay. Put right up
I didn't think that it went in a certain, like I thought it.
Where's your sketch?
Right
Okay.
there.
Zoom in.
So, if it starts at the origin, I just drew. I didn't even write in the numbers. I just drew the 10 seconds, 50 seconds up,
I'm gonna turn the light on.
so they can figure out what it looked like.
Okay, so we're having a lot of side chatter. If we could just have one person talking, that'd be nice. Thank you. Okay, so in terms of why do you have different circles there?
Because the first part of the question, or the first A or B, was the 10 seconds out, and the second was 50. So I just did it on the same one.
Okay, so does everybody agree that this thing was centered at the origin?
Yeah.
They gave you that information. And so if it is at 10 seconds, what is the radius? Doesn't it go at 30, what did they say, 30,000 or 300,000?
Times 10.
Okay, was it 300,000 per second?
Yes.
Okay, so you have 300,000 per second, so in 10 seconds, what do you have? 3 million. Okay, so then what is your equation?
X squared plus 1 million or squared.
3 million squared. Now, boy, that's a big number. You think? Yeah, 3 million squared. So, how might you rewrite this? Times 10 to the whatever. Okay? Remember scientific notation? This is all about scientific notation. Now, in doing this problem, I thought about, how many people thought of scientific notation? Anybody? You thought about it. Okay, well, good. I'm glad you thought about it.
I still don't
So,
understand.
pardon me?
I still don't quite understand how to do that.
Okay, so I'm gonna give you a brief review right now. We'll be doing a lot more computation later on. So if let's just see what you need to know. But thank you, Cassie, for sharing that. Okay, so would you agree that this is what it should look like? And I'm going to zoom out. Everybody good with, that's what the equation should look like, because that's our radius. Everybody good with that? How do you write 3 million in scientific notation?
3 times 10 to the 3rd.
Good. So I know that when I'm writing any number in scientific notation, I have a decimal point after the first digit. Okay, well, it would, if I had, it's always in scientific notation, I always have, Matt, it's always a 0 after the first digit. So if I had a very, very small number, and my original number was 0.00543, my decimal, to write it in scientific notation, I would put the decimal after this. These are digits, I stand corrected, but after the first non-zero.
So you wouldn't put a decimal if 3 is estimated.
I'm sorry?
If that 3 is estimated, you wouldn't. Never mind, it's not important.
Okay, in this particular case, it wasn't, they told us that it was, what, 300,000, what was it?
300,000.
300,000 kilometers per second. So after 10 seconds, I know that it's gone that amount. But to write it in the equation, I know that this has to be squared. Now to write this in scientific notation, I know that this is going to be 10 to the what? Okay, yeah, it's going to be 10 to the, well, not yet. You've squared it before. But this is going to be 1, 2, 3, 4, 5, 6. So is 3 times 10 to the 6 equal to 3 million?
Yes.
Okay. Is this easier to square? Okay? Because I could just say, well, what is 3 squared times, and if you remember, when I have an exponent, the rules for exponents are that we add when we're multiplying, but if I'm raising an exponent to a power, I do?
Multiply.
I multiply, okay? Because this means 10 to the 6th times 10 to the 6th would be 10 to the 12th, but when I have it this way, it would be 6 times 2 is 12. Okay, so can I rewrite this as 9 times 10 to the 12th?
Yes.
Okay, so that would be my final answer for writing that.
I thought you just said you multiplied them.
I did.
6 times 6.
2 times 6 is 12.
So if you have three,
So why don't you
that's 3 million.
Okay, yeah, it was 3 because the original number was 300,000 and it traveled for, it's per second, so in 10 seconds, when I have another 0, I'm gonna multiply it out. Stephen?
Would you rather us do it that way or should we
Yes,
do-
it's a lot easier. It's a lot easier. I will be reviewing in more detail the whole exponent things, but I'm just kind of, and I'm not assessing you or testing you on this. I'll give you a separate test on this, on exponents. But for those of you who might have remembered, it would have been 9 times 10 to the 12th. Okay? So after 50 seconds, it's going to be how much per, after 50 seconds, won't we be, I'm going to erase this on the board. Okay, in 50 seconds, well, I know I'm going to have 115 million, okay, but to write that, I'm going to write, I wrote that in scientific notation because to write it in the equation of a circle, it's going to be, let's see if I can get that over there.
Maybe 10. No, because it's second. So.
Okay, so I'm putting my decimal right here, and it's 1, 2, 3, 4, 5, 6, 7 places. So it is 1.5 times 10 to the 7th. The decimal always goes after that first digit. It's
So if it
always,
was like 255, it would be 25.
255 would be 2.55. And then you count how
How many
times
are left?
10 to the 2nd. Stephen?
On your calculator, when there's not enough room for enough zeros, what does the E mean?
Exponent.
Oh, okay. That's what I thought.
Okay, the exponent. They're telling you what the exponent would be.
Okay.
Okay? Okay, so does that make sense? And then again, I'm going to do 1.5 squared, which is 225 times 10 to the 14th. Okay, so this was just kind of practicing some exponents. And then after n seconds, it's going to be 300,000 times n. And then I'm going to have 300,000 times n squared. And I know that I have to multiply everything by 3 to 3n. I rearranged it, 3n times 10 to the 5th squared, which would be 9n squared times 10 to the 10th. Okay, so these were just getting you to think about exponents. Okay, so that takes care of number 26. So number 26 is, so what shape is this? Is it just a circle or is it in space? It's going to be a sphere. Okay, pretty amazing stuff. All right, so that was number 26.